Hi, this is Tej Arora. I'm an AWS Certified Solutions Architect Associate. In the AWS Quick Learn series, I will cover AWS services and features in short videos. These videos will provide a quick 360-degree coverage of a service or feature. They are suitable for those preparing for an exam or an interview or just want to refresh their knowledge. In this video, I will discuss IAM, the Identity and Access Management Service. Let's start with an introduction to IAM. So what is it? Essentially, IAM is a service that manages identities and manages access to AWS services and resources. Hence the name IAM, Identity and Access Management. Now, access has two parts to it. One is authentication and the other is authorization. So access is permitted when an authenticated entity has the authorization to access a resource or a service. Now, there are rare exceptions where anonymous access is allowed. For example, an S3 public bucket. And there are also some STS APIs that allow that. But in practically all cases, access is given only when an authenticated entity has the necessary authorization. Now, IAM manages users, groups, roles, and permissions. We'll talk more about this later. It is a free service and it's a global service, which means you don't need to choose a region before using IAM. Now, use cases, almost everything that happens on AWS goes through IAM. Whether it's a end user interacting with an AWS service or resource, whether it's a service interacting with another service or a resource, IAM is in the path. IAM is used for sophisticated access control to resources and APIs to those resources. The access control is fine-grained. You can specify what actions can be performed on which resources and which entities can have access. You can, in addition to that, refine the control further based on conditions such as time of day, whether SSL is used, whether a multi-factor authentication device is used, the IP address from where the request is invoked, and so on. Now, given the sophistication of the access control capabilities, IAM makes it easy to delegate access for specific job functions. For example, you can have finance responsibilities, security administration, system administration responsibilities assigned to specific persons. And you can also have this delegation work across accounts. So this is very useful for an organization that has multiple AWS accounts. IAM can also be used for identity federation, where you can use your own existing identity providers and federate access to those identities to AWS. You can use IAM to monitor and fine-tune access policies continuously by removing access to resources that are not being used. Now, it's worth mentioning here that there are some access control scenarios outside of IAM as well. For example, EC2 instances and RDS instances have security groups that control access. Access to an EC2 instance can be controlled with an SSH key pair. And RDS databases have specific users that can access the database. All of these have nothing to do with IAM access control. Now let's look at the key artifacts and concepts in IAM. It manages users, groups, roles, permissions, and credentials. Let's look at each of these. So note that the user that creates the AWS account is referred to as the root user and has unbounded permissions. So one must be careful using the root account. It's recommended that it's not actively used. It's better to create additional IAM users to perform activities. Now, an IAM user could be created for either a person or an application. The name of the user can be any ASCII string. It can be an email address or any hierarchical string. Now, to a user, permission policies can be applied. A user has a password which is suitable for humans, and the scenarios where the password is used is for the management console sign-in using these URLs, either the sign-in endpoint, or you can have your account ID or a custom alias as part of the URL. Note that when a user signs in to the management console, the activities in the console are governed by the permissions that the user has. The password for the user can also be used to sign in to AWS forums, the support center, and marketplace. Users can optionally be given an access key. An access key can be created for them. This is suitable for applications to make requests to AWS resource. A user may also be associated with Git credentials, and this is optional and it's used with AWS code commit. And a user may also have an Amazon Key Spaces credential, which is optional and usable with Amazon Key Spaces. A group is essentially a collection of users. And just like permission policies can be applied to a user, they can also be applied to a group. Groups makes it easy to manage permissions. If you have hundreds of users, instead of assigning permissions hundreds of times to each of the users, you can put users in groups and assign permissions to groups. And the users in the groups inherit those permissions. Roles. So access that is controlled using roles is referred to as role-based access control. Roles are essentially used to facilitate and define access. What roles allow is to enable delegation of access without sharing any access keys. A role is sort of like a hat that someone can put on, and it gives them some powers. There's two parts to a role. There is a trust policy and a permissions policy. A trust policy says which entities can assume that role. Entities include an account, a user, a service, or a resource. In other words, who can put on this hat? In addition to the entities mentioned here, an EC2 instance can be assigned a role as well. And there are also service-linked roles. Essentially, these roles can only be used by the service that they are linked to. And that service, it can assume that role to access resources in other services. And examples of this include the RDS service uses a service-linked role to create EC2 instances to run the database. Note that the trust policy of a service-linked role cannot be modified because it is linked to a specific service. The permissions policy is about what permissions are associated with the role. In other words, by putting on the hat, what powers do you get? It has to be assumed first by calling an STS API before it can be used. And behind the scenes, this API returns temporary credentials, and we'll talk more about this in a few minutes. Note that when a request is made to AWS, only one role can be assumed for that request, although the entity that's making the request can be associated with many roles. Now let's look at permissions. They're typically known as policies, but let's be specific and call them permission policies. Basically, a permission policy is an editable JSON document, and if you find JSON hard to read, you can also view a policy on the console in the policy summary. Now, what are the types of policies? There's identity-based policies. That is, these are attached to identities such as users, groups, or roles. And what this does is it makes it easy to manage permissions. The identity policies also specifies what the identity can access. And there's two types of policies: managed policies, which are pre-created by AWS or by the user, and they are stored and can be used anytime, and inline policies, which are just embedded at the time of use. Next, there's resource-based policies. These are attached to resources as opposed to identity policies, which are attached to identities. For example, there's a policy that you can attach to an S3 bucket. What the resource-based policy specifies is which identities can access the resource, whereas the identity policy specified what resources can be accessed by this identity. There's also an organization service control policy, or SCP. This policy applies to an entire account, so every access by every principal in the account is governed by this policy. So this makes it easy to govern accounts centrally. There is a session policy, which is when a temporary session is created programmatically, a policy can be specified as a parameter. And there's access control lists. These are specifically used for cross-account access. So you attach an ACL to a resource in one account, and the ACL specifies the principals in the other who can access the resource in this account. It's similar to a resource-based policy, but it's specifically for cross-account only, and there is no JSON policy document associated with it. And finally, there is a policy called a permission boundary. What the permission boundary does is it limits the maximum permissions for an identity, a user or a role. It's sort of like a high watermark for permissions. Permissions boundaries are not granting permissions, they're just limiting the maximum permissions. And as I mentioned, permission boundaries can be associated with users or roles. Now that we've seen the different types of policies, let's look at what a policy looks like. So a policy has these elements. There is an effect element, which is either allow or deny. There's an action element, which specifies a set of actions. For example, S3 create bucket. There is also a not action element, which is the inverse of action. So these are all the actions not allowed, and anything not mentioned here is allowed. There's resource ARNs. These help identify which resources pertain to this policy, or there can be resource tags which identify resources. Using tags to identify resources in policy is also referred to as attribute-based access control. And there can be conditions for access. For example, whether there is an MFA sign-in. Now that we've covered what policies are, how are policies evaluated? It's a little tricky. So let's go through the flow. When a request comes in for access, to begin with, access is denied by default to all resources. And all the policies are evaluated for the request. The identity-based policies, resource-based policies, organizational SCPs, session policies, and permission boundaries all are evaluated. If there is an explicit allow in any of the policies, access is allowed. If there is an explicit deny in any policy, that overrides all allows. So deny trumps allows. Now, net permissions at this point are the identity policy, its intersection with the permission boundary, which means whatever is allowed by both of these. And then it's combined with the resource policy. And then the next step, the permissions we have calculated so far is intersected with the service control policy and the session policy to come up with the final net permissions the request has. Now, what are credentials? There's many types of credentials. Passwords, certificate, SSH keys, MFA devices, the access keys, and there's also temporary credential. Passwords, one can create a password policy that governs passwords. Certificates are used for server-side authentication when there are HTTPS connections to the server. They are also used for client-side authentication, for example, signing SOAP requests. Normally, certificates are managed by the AWS Certificate Manager, ACM, but in regions not supporting ACM, IAM can also be used. SSH keys are used for SSH access to an EC2 instance. So they are not IAM artifacts, they are EC2 artifacts. But in IAM, you can associate SSH keys with users that are specifically for use with code commit. MFA devices are another form of credential. We'll talk more about MFA later. Access key is a long-term credential. It can be optionally assigned to an IAM user. It can be used to authenticate CLI or API calls. Now, corresponding to long-term credentials, there's also temporary credentials, also known as a token. We'll talk more about this later. Now that we have covered the artifacts and concepts, let's look at the features of IAM. So one of the features is the support for multi-factor authentication. What this helps do is it provides additional security by using an extra code from an MFA device. The code from the device is constantly changing, so it's a lot safer than static passwords, which can be lost or stolen. One MFA device can be configured per IAM user. They can be physical or virtual. And let's see where all MFA can be used. So for the management console login, the UI asks for an MFA code if the user logging in has been configured to require login with MFA. And this is highly recommended for root users because of the power associated with the root user. MFA code can also be used for API access. To enforce MFA authentication during API access, you can add a condition to the policy attached to the user or the resource. And in order for the API call to have MFA authentication in it, when credentials are obtained, the MFA code needs to be passed in. And outside of IAM, MFA is used by S3 as an additional protection mechanism for deletion operations. Temporary credentials is a powerful feature in IAM. Let's start by looking at what are the advantages of this feature. So applications do not have to embed any security credentials along with them. They just obtain temporary credentials as needed. There is no need to worry about rotating access keys, and there is no need to create IAM entities for every user of the system. You can have non-IAM users use temporary credentials to access the system. So what are temporary credentials? They can be programmatically obtained from the STS service, which is a global service, but to reduce latency, there are regional endpoints available. Now, who can obtain temporary credentials? An IAM user or a federated user can obtain. A temporary credential is same as an access key, except it has a limited lifetime, which ranges from minutes to hours. Note that temporary credentials cannot be revoked before the expiration time, but the permissions associated with them can be altered. Now let's look at what permissions are available to a temporary credential. They are a combination of permissions of the requesting entity, and we said IAM users or federated users are the entities that can request, and the role being assumed if it's applicable, and an optional policy parameter passed to the STS API. It's not a good idea to use the root user to request temporary credentials because a root user has unlimited permissions. It is better to create a separate IAM user. If you do that, you can limit the permissions of temporary credentials even after they're created, and that can be done in real time by just modifying the permissions of the user, which cannot be done for the root user. So while temporary credentials cannot be revoked after creation, their permissions can be limited in real time. Temporary credentials are dynamically generated, and on expiration, they can be regenerated. Once a credential expires, access using that credential is denied. And note that certain features, such as roles and identity federation, are actually built on top of temporary credentials. Identity federation is another powerful feature. It allows identities outside of IAM to access AWS. Now, outside users can actually use their own existing credentials to access AWS. So outside users can access APIs by obtaining temporary credentials and using them. Outside users can also access the management console. And there's two ways to do that. One is to programmatically obtain temporary credentials, pass it to a federation endpoint, and get a sign-in token, and then construct a URL with that sign-in token and sign in. The other way is to post a SAML assertion to a sign-in endpoint. Now, the identity federation feature is implemented in STS, the security token service, which supports SAML 2.0. Let's look at the types of identity federation. There's enterprise federation, where the users of the Microsoft Active Directory, for example, the identities in the Active Directory can access AWS, and the web identity federation, where any OpenID Connect compliant provider, examples are Google and Facebook, those identities can access AWS. For mobile apps, Amazon Cognito is recommended to be used for identity federation. And also note that for federated users, MFA authentication is not supported. Another powerful feature of IAM is support for cross-account access. This is necessary for companies that have multiple AWS accounts to manage. Now, resources in an account can be accessed by users in another account. There is a role-based cross-account access as well as resource policy-based cross accounts. Access Analyzer is a feature that helps identify resources that are accessible to external entities. IAM Console Search, it supports powerful queries which can include actions such as create role, edit policy, add user, and what it returns is actionable links. This makes the life of the security administrator a lot easier. Credential Report, it helps identify and remove unused credentials to stay aligned with the principle of least privilege. Now, last access time, it is displayed for users, groups, roles, and policies, and this helps identify permissions that are not used and therefore reduce unneeded and unused permissions. Once again, helping with the principle of least privilege. As for compliance, IAM service is in compliance with a lot of standards such as SOC, PCI, FedRAMP, and so on. The policy simulator is an interesting feature. It helps validate existing policies and troubleshoot any issues in the policies. For example, a user expecting access is denied access. It can be used to test changes to policies before deploying them. To use the simulator, you provide policy info, the desired actions on a specific service or resource, and other contextual info, and the simulator simulates a request, and you can see whether the result is as expected. IAM data consistency model is eventual data consistency. IAM is a global service, and for high availability and to maintain low latency, it replicates its data worldwide. So which means a change made to an artifact, it may not be visible in real time across all regions. Don't depend on any change to an IAM artifact such as a user or a policy being visible in real time across all regions. Let's look at some limits that apply to IAM. These are all defaults, but they can be adjusted. Maximum users per account is 5,000, maximum groups is 300, and maximum roles per account is 1,000. And the number of policies you can attach to a user or a role is 10, and the number of groups that a user can be part of is 10. Integration with other services. Almost every service integrates with IAM for controlling access to its resources. Now, let's quickly look at how IAM facilitates the 5 pillars of the well-architected framework. Operational excellence. All IAM STS access is captured in CloudTrail and can be analyzed. Now, for security, there are recommended best practices to follow and features in IAM that strengthen security. So let's look at quickly the recommended practices to have strong security. Follow the principle of least privilege and continuously remove unused credentials and permissions. And features that help with that are credential report and last access time. For very sensitive operations, such as a root user login, enforce MFA, have a strong password policy, use roles and groups for granting permission. It's much easier to manage permissions when you have a large number of users. Rotate security credentials such as passwords through the password policy, encryption keys and access keys, and so on. Use roles for access from EC2 instances instead of access keys. So this means there is no need to copy access keys. You don't have to worry about rotation of access keys. Apps that run use temporary credentials returned from STS, and you can do fine-grained access control on EC2 instances in real time by modifying the role or by assigning a different role to the EC2 instances. And you can manage permissions of multiple EC2 instances in one operation. And avoid using the root user for active operations. Create a separate IAM user and assign admin privileges to that user if necessary. Other aspects that bolster security of your applications. The IAM data is encrypted at rest, and HTTPS only access ensures encryption during transit. The IAM and STS services are also protected by AWS Global Network Security. Only clients with strong security are supported. So TLS 1.0 or later must be used by the client, and strong cipher suites must be used in the clients. Every request to AWS has to be signed with long or short-term credentials, and the access control can use network origin parameters to limit access, such as IP and which VPC is used, etc. As for the reliability pillar, the IAM data is replicated worldwide, so there's a tremendous amount of redundancy, and STS runs regional endpoints for redundancy as well as efficiency. And because data is replicated worldwide, latency from any part of the world is low, and that makes for very efficient calls. As for cost management, it's a moot point because IAM is a free service. This completes my overview of IAM. Thanks for watching the video. If you found it useful, please consider clicking on the like and subscribe buttons. If you can leave a comment about what you liked and what could improve, I would really appreciate that. Thanks again.